Okay, so this is the substitution rule involving constants. So it's a little bit slightly different twist of the same problem that we've already gone through with basic substitution. Here, notice with this problem, you've got exponents that are 1 degree apart. And that's key because when you take the derivative of an exponential, right, you apply the power rule with n minus 1. So that should give us a hint as to what we should let u equal. So if you let u equal the higher exponent, so we're going to let u equal, excuse me, x to the 6th minus 3x squared. Take the derivative. All right, so find du. And du is 6x to the 5th minus 6x. Solve for dx. In this equation. And this is a little bit, not much, but a little bit trickier because it's not intuitively obvious as the other ones were that what's left over here, that we could do a direct substitution of du because we're off by factor of a constant. So when you solve for dx, you get du over, I'm going to factor out the 6, x to the 5th minus x. So now you can start to see that we're getting, grab a different color, right, we're getting down to something close to what we've got here. So let's make our substitutions. You've got u to the 4th power, x to the 5th minus x, and I'm going to substitute in for dx, which is du over 6x to the 5th minus x. So algebraically, let me grab another color here. These two terms will cancel out, and you're left with, I'm going to pull out the 6, the 1/6. You're left with 1/6, the integral of u to the 4th du. So this is why it's called substitutions involving constants, because you're actually going after the constant when we do the substitution for du. Take the antiderivative, which is just simply applying the power rule, and you're left with 1/6 u to the 5th over 5 plus a constant, and just substitute back in for u. I just simplify that. Substitute back in for u. And you get your answer. Oops. It's the problem with the videos. If I make a mistake, I can't go back and really fix it after I've done it. So hopefully these are good. Okay, that's it. So it's a variation on the substitution rule involving constants.